My dear students, in my previous video, I introduced the topic probability for CBSE 12th standard students, and I explained the definition of conditional probability also. Now in this video, I am going to continue the properties of conditional probability. Suppose E and F are any two events of a sample space of S of an experiment. Suppose S is an experiment. In that experiment, E and F are any two events. Then the first property of conditional probability is probability of sample space S given that the event F has already occurred. P of S by F. P of S slash F means probability of S given that the event F has already occurred, and the probability of F, event F, given that the event F has already occurred. Probability of S slash F and the probability of F slash F are 1. That's the first property. That is, we know that the probability of sample space S, given that the event F has already occurred, P of S by F is equal to P of N, you know the result, P of S intersection F by P of F. That is the formula for P of S by F. S slash F is P of S intersection F by P of F. P of S intersection F, you know, S is a sample space and F is any event on that S. Therefore, S intersection F is F itself. S intersection F is F only. S intersection F is F. Therefore, this is P of F. By again denominator P of F by P of F is 1. That's our first result. Next one, probability of the event F, given that the event F has already occurred, that means P of F slash F is equal to P of F intersection F by P of F. You know, F, any event intersection with that event, F intersection F is also F only. Therefore, this is P of F by P of F, second one. That's our property. Now, second one, property 2. If A and B are any two events, if A and B are any two events of a sample space, yes, and F is an event on S, such that P of F is not equal to 0, then probability of the event A union B, given that the event F has already occurred, that is P of A union B slash F is equal to P of A slash F plus P of B slash F minus P of A intersection B slash F. That's our second property. If A and B are any two events of a sample space S, and F is any event on the sample space S, such that probability of F is not equal to 0, then probability of A union B slash F is equal to P of A by F plus P of B by F minus P of A intersection B by F. That's the second property. Suppose A and B are disjoint events. Here, given that A and B are any two events, now in this case, if A and B are disjoint events, we will see. So, in particular, the event A and B are disjoint events. Here A and B are disjoint events. In this case, if A and B are disjoint, you know A intersection B is 5. A and B are disjoint events, then A intersection B is null set. Therefore, probability of A intersection B is 0. Therefore, the property 2, probability of A union B slash F is equal to P of A slash F plus probability of B by F minus P of A intersection B slash F is 0. Therefore, if A and B are any two events, that third term will not occur, that is P of A union B, given that the event F has already occurred, is P of A by F plus P of B by F. That's the property 2. Next, property 3. If E is any event on a sample space S, property 3. If E is any event on a sample space S, so E dash is its complement event, and E dash is the complement event of E. E dash is the complement event of E. Therefore, E, since it is a complement event, E dash is a complement event of E. E union E dash equal to S. E and E dash constitute the sample space S, because E is any event, E dash is its complement, therefore E union E dash is S. So this property says that probability of E dash slash F is equal to 1 minus probability of E slash F, where F is any event, where F is any event on S. F is any event on S. This is the result. P of E dash, given that the event F has already occurred, is 1 minus of P of E by F. Okay. You know P of S, we know that P of S slash F is equal to 1. We know that P of S slash F, that's our first property. Therefore, S can be replaced by P of E union E dash slash F equal to 1. E union E dash slash F is equal to 1. Since E and E dash are disjoint events, P of E union E dash slash F is equal to P of E slash F plus P of E dash slash F, because E and E dash are disjoint events. Because E and E dash are disjoint events. Disjoint events. P of A union B by F is equal to P of A by F plus P of B by F. So this idea, the same idea is applied here. P of E union E dash is slash F, that is E and E dash are disjoint event. We get P of E slash F plus P of E dash slash F. But we know that this is result 1. This is 1. Therefore, this is P of E slash F. This is 1. Therefore, P of E slash F plus P of E dash slash F is equal to 1. So from this, P of E dash slash F is equal to 1 minus. What is that? That is the property. Yeah. This is a will come. From this expression, you keep that P of E dash slash F on the left hand side itself. Listen. See. So this result gives you P of E slash F plus P of E dash slash F is equal to 1, you know. So therefore P of E dash slash F is equal to 1. You bring this term to the right hand side, is 1 minus of P of E slash F. Hence the property. Hence the property. 3. Okay. These are the 3 properties of our conditional probability. Now we will solve some more problems in the exercise. Now we are going to solve some problems in the exercise. Now I am going to solve some problems in the exercise 13.1. First problem, given that E and F are any 2 events such that P of E is 0.6, probability of E, and probability of F is 0.3, and probability of E intersection F is 0.2. Then find P of E slash F and P of F slash E. Probability of the event E when F has already occurred. That is P of E slash F, you know, P of E intersection F, formula P of E intersection F by P of F. You know P of E intersection F is 0.2 by P of F is 0.3. So this is nothing but 2 by 3. That's all about the probability of event E slash F is 2 by 3. P of E slash F. Second one is P of F slash E. Probability of an event F when E has already occurred. It's also P of E intersection F by P of E. This is our formula. P of E intersection is 0.2 and P of E is 0.6. So this is 2 by 6, that is equal to 1 by 3. So first one is 2 by 3, second one is 1 by 3. Okay, that's all about the problem. Next one, second problem. Next problem. Given that P of A, probability of A is 0.8, probability of B is 0.5, and the probability of B by A, probability of B slash A, probability of event B when A has already occurred is 0.4. Okay. Then find P of B by A. Then find P of B slash A, probability of event B when A has already occurred. P of B by A. By definition, P of B slash A is equal to P of A intersection B by P of A. You know P of A intersection B. Where is P of A intersection B? You have to find that. Because you know P of B by A is point. This implies P of B by A is 0.4 is equal to P of A intersection B by P of A is 0.8. So from this cross multiplication, this implies P of A intersection B, P of A intersection B equal to 0.4 into 0.8. On cross multiplication, you will get 0.4 into 0.8, that's equal to 0.32. So P of A intersection B is 0.32. From this, now listen, if P of A is 0.8, P of B is 0.5, P of B by A is given as 0.4, find P of A by B, sorry, not B by A, find P of A slash B, probability of event A, given that the event B has already occurred. For the P of A by B, to find out P of A by B, we want P of A intersection B. That should be determined from this expression, P of B by A. Now, we want P of A by B, A slash B, again by formula P of A intersection B by P of B. You know P of A intersection B, 0.32, and P of B, 0.5. So this is equal to 32 by 50. You on simplification you will get 32 by 50. This is equal to 16 by 25. That is nothing but 0.64. So P of A by B, P of A slash B is equal to 0.64. This is the answer for the problem. Okay. And from the same problem, one more result they are asking P of find P of A union B. Find P of A union B. P of A union B by formula you know P of A plus P of B minus P of A intersection B. This is the formula. You know P of A 0.8. plus P of B 0.5 minus P of A intersection B 0.32. So 0.8 plus 0.5 is 1.3 minus 0.32. This is equal to 0.98. Okay. So P of A union B is 0.98. That's all about the problem. So thereby I conclude this video, and we will continue the remaining problems in the next video. Thank you.